All right, today I'm going to talk about section 4 from chapter 10, and this is compound events, so furthering into probability. So something, hopefully you remember probability just being the number of favorable outcomes over the number of possible outcomes. Well, now we're adding compound events. So this would be like when you flip a coin and spin the spinner. There are two things happening. So it's a compound event, just like a compound word, you guys, okay? So same thing. Flip a coin, roll the number dice. More than one event is happening, okay? So a lot of vocabulary again. So sample space, that's kind of an important piece of vocab here. And my printer is losing all ink colors. That's why everything looks funky, okay? So the set of all possible outcomes of one or more events is called the sample space, okay? You can use tables and tree diagrams to find the sample space of two or more events, okay? So this is kind of a nice graphic, finding a sample space. That means how many outcomes are there. You randomly choose a crust and a style of pizza, find the sample space, how many different pizzas are possible. So what are all the possible outcomes? So how many are in the sample space? Not what are the outcomes, what's the numerical amount of the sample space. So you could see you had two types of crust and 4 styles of pizza, Hawaiian, Mexican, pepperoni, and veggie. I know it's highly debatable to have pineapple on pizza. It's a go at our house, but I know a lot of houses say no. So here we go. Two types of crust. So you can have a thin crust Hawaiian, thin Mexican, thin pepperoni, thin veggie, right? And then the same thing with stuffed. So you can make this tree diagram and it will give you all of your outcomes here. And then if you count them, you can see there are 8 different outcomes in the sample space. So the sample space, again, is the numerical answer versus what are the outcomes, okay? Now, I want you to think about how this would change if I added, a deep dish crust, okay? This would have 3 crusts and 4 different styles of pizza. And this is where we like to use something called the fundamental counting principle, okay? This is a lot simpler. It's really nice. So the fundamental counting principle is an event M has M possible outcomes, okay? And event N has N possible outcomes. So the total number of outcomes of event M followed by event N is M times N. Again, that's the algebraic workup of it. I know it's funky, okay? Now, think for a second. I have my spinner here that you've seen a few times now. How many possible outcomes are there on the spinner? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes on the spinner. And then I have my number cube, which has 6 possible outcomes. Okay? I can roll a 1, and that can get paired with 0. I can roll a 1, and it can get paired with 1. I can roll a 1, it can get paired with 2. I can roll a 1, it can get paired with 3. And you can see how this would be a nightmare of a tree diagram, okay? But we could use the fundamental counting principle. 10 times 6 is 60. So there would be 60 combinations here, okay? So let's look at this example here. All right, we have the total number of possible outcomes in rolling a number cube and flipping a coin. Well, we already know a number cube has 6 outcomes and flipping a coin has 2 outcomes. So I bet you can very, very quickly give me the answer of 12. But again, there are 2 methods, okay? And for the sake of learning, I will show you how to make a table, right? Tree diagram, table, heads, tails, 1, 2, 3, 4, 5, 6. There's my number cube. Okay, so if we were putting this all together, right, you could see that you could roll a 1 with heads, a 1 with tails, a 2 with heads, a 2 with tails, a 3 with heads, 3 with tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, 6 tails. So you can see that there are 12 possible outcomes right here, okay? So the sample space is 12, all right? Now, what are all the possible outcomes? There they all are, okay? Method 2 is just using your fundamental counting principle. Event 1 was the number cube. And that has 6 outcomes, okay? Event 2 is the coin, and that has 2 outcomes. Okay, so here's event M, here's event N, here's its outcomes, so we just do 6 times 2 equals 12. So there are 12 outcomes. Okay, fundamental counting principle, working it out. There are times and places for both, but I believe this is one you will use a little bit more. Okay, let's look at the next example, 3. Again, I apologize for my printer. Finding the total number of possible outcomes. How many different outfits can you make from the t-shirts, jeans, and shoes in the closet? Use the fundamental counting principle. Yay, because sometimes tree diagrams can be kind of a nightmare. Okay, event 1, choosing a t-shirt has how many possible outcomes? Well, if you go in your closet, okay, you can see that there's 1, 2, 3, 4, 5, 6, 7 possible outcomes. Choosing jeans, 1, 2, 3, 4. And choosing shoes, 1, 2, 3. Okay, I know when I talk about the fundamental counting principle, we talked about, M times N, but, it could be L, M, N, O, P. It depends on how many events there are, okay? I'm almost done. It's okay, Chloe. I'll be there soon. Okay, so, sorry, that was my kid. So I have 7 times 4 times 3, which is 84. So there are 84 outfit combinations that you could make. Okay, so that's the fundamental counting principle. Okay, now we're going to move on to this idea of a compound event. Okay, compound events are 2 or more events. Okay, as with a single event, the probability of a compound event is the ratio of the number of favorable outcomes to the number of possible outcomes. So we can use things like the fundamental counting principle to figure out what that, denominator, that lower part of your ratio would be, okay? So if we want to look at example 4, which is here, it references example 2, so we might have to go back to that. In example 2, what's the probability of rolling a number greater than 4 and flipping tails? Okay, so if we go back to our chart here, greater than 4 would get me here, 5 or 6, and then flipping tails would eliminate these 2. So how many options are there? There are 2 options. Okay, so I know that the favorable outcome here, so I know that the probability of my event, remember event goes here, greater than 4 and tails. I had 2 favorable outcomes in that situation, and there were 12 total outcomes made, okay, or available. And then that, of course, can simplify to 1/6. Or, you could write everything as a percent, okay? So again, favorable outcomes over total number of outcomes. That's just what probability is. All we're doing now is adding a little bit more to the mix, okay? You can kind of look at these a little bit separately too, since it's the fundamental counting principle. How many numbers do I have greater than 4? I have 2 out of 6, which is 1/3. Okay, so and we will get into all that a little bit later with the next section. All right, so if we look at example 5, it says find the probability of the compound event. You flip 3 nickels. What's the probability of flipping 2 heads and 1 tail? Again, we can make a giant tree diagram, okay? And this is how something like this would work. You have heads, you have tails. Those are the possible outcomes for my first nickel. Then this one could go to heads, and then this one could go to tails. This one could go to heads, and this one could go to tails. So this is my second nickel. And now I'm gonna flip my third nickel. This could go to heads, this could go to tails. Heads, tails, heads, tails, heads, tails. So this one here was heads, heads, heads. This one here was heads, heads, tails, heads, heads, tails. Then we had heads, tails, heads, heads, tails, heads, sorry. Heads, tails, tails, heads, tails, tails. That's an H. Then we come down here, tails, heads, heads, tails, heads, tails. Then we have tails, tails, heads, tails, tails, tails. It gets confusing for me too. I prefer the fundamental counting principle, okay? Now, what is the probability of flipping 2 heads, 1 tail? Well, do we know how many outcomes we have? 1, 2, 3, 4, 5, 6, 7, 8. So my sample space is 8, okay? And then where do I have 2 heads and a tail? 1 there, 1 there, and 1 there. Okay, so the probability of this happening is 3 out of 8, okay, or 37.5%. All right, now say you didn't want to do this method, which most of us do not want to do. You can kind of look at them all individually. Okay, event 1, which is nickel 1, has 2 outcomes. Event 2, which is your second nickel, has 2 outcomes. And event 3, which is your third nickel, has 2 outcomes. So 2 times 2 times 2 gets you 8, which is the same thing that we got over here, okay? I know that's kind of weird, probability. If you think about it, it makes a lot of sense, but can also be pretty confusing, okay? So I want you guys to pause it. Please pause it and try these on your own. And then unpause it and check to see if you got them right, okay? Okay, pause it now. Did you really pause it? Okay, I'm just gonna keep my fingers crossed that you did. So question 4, the probability of rolling at most a 4 and flipping heads. This one was 1/3, okay? Question 5 was 1/2. Question 6 is 1/36. And question 7 is 1/8. Of course, these can all be written as percentages. Also, this is 33⅓%. Notice they're writing all their percents, not as a repeating decimal, but as a fraction, okay? Fractions are the way to go. Example 5 obviously was 50%, 1/36. I believe this is 2 7/9%. And then 1/8 would be 12.5%. All right, go ahead and give those all a look through. If you need some more examples, you guys, head to your student ebook. All of these examples that I'm doing are right in here, okay? And in all these examples, you guys, there are every example that I do has a video tutorial in here for you, okay? If you want a few more examples of things. Okay? Hope that helps. See you later.